Now I am going to explain you how to implement stack operations using linked list. We all know that stack can be implemented by inserting an element from one end and item can be removed from the same end. For this implementation, I can either choose the front end of the linked list or the rear end of the linked list. But I have to insert the element and remove the element both from the same end. If I am going to insert an element from the front end, I have to remove the element from the front end itself. Or if I am inserting an element from the rear end, I have to remove the element from the rear end itself. I choose to insert the element and remove the element from the rear end. Now let us see how to implement this program. Because we all know that linked list is a collection of nodes. A node is having two parts, a info part and a link part. The info part can be of any data type, integer, float, long, double or anything. And the link part will hold the address of the next node. If I am holding the address of the next node in the link part, I have to, the link part should be of pointer type. It is because it is holding the address of a node, the data type of the link should match the data type of a node. The data type of the node is a structure. So hence, firstly, I'm using a structure to represent the nodes. Struct node int info. I'm defining link and the data type of this link should match the data type of the node whose address it is going to store. Hence, the data type of the link should be struct node. Because it is a pointer variable, a asterisk mark is written. Now each time when I want to define a pointer inside my program, I have to write struct node star. Instead of writing a lengthier one, I choose to write node node in capital letter using the type def. Coming to the getNode function, x is defined as a pointer using node data type. Now precisely, I do not know what is the size occupied by the structure node. To know the size of the structure, I am using the size of operator and I am passing the structure as an input to the size of function. It will return me how much memory is required for that structure. So that amount of memory is passed as an argument to the malloc function, which is a memory management function. The malloc will allocate me that much amount of memory in my computer and return me the address, which I'm going to assign to the pointer x. Now the data type of the pointer x is of type node. Hence, I am explicitly typecasting it with the help of node there. And I return the address of that allocated memory using the return statement. That is how getNode function works. Next, insert rear. If I want to insert a node at the rear end of the linked list, first I have to check for two conditions. whether the linked list is having more number of nodes or the linked list is empty. Before that, I am declaring two pointer variables, current and temp. Temp is equals to get node. The get node function is called, which I explained earlier. The get node function will allocate memory which is required to store a node, and the address is returned to temp. Later, I am assigning the value of item to temp's info part. Because I am going to insert the node at the rear end of the linked list, the last node of the linked list should always contain null value in its link part. Hence, I am assigning null to the link part of temp. Now, before I go and start insertion, I check whether my linked list is empty or it is having few nodes. If my first is equals to null, this condition will be true only when there are no nodes inside my linked list. In that case, I return the value of temp, so that temp will be the only node inside my linked list. If this condition becomes false, that is not the case. Next, what I do is I assign the address of the first node to the current pointer. In the while loop, I iterate this while loop until the current's link part will become null. That is, until the current's link part is not equals to null, I keep on iterating this loop. What I do here is I assign the address of the next node which will be present in current's link part to current. So I first check whether current's link part is not equals to null. If it is not null, what I do is the address of the next node which is present in the current's link part, I will be assigning it to current. Hence, the current pointer will now hold the address of the next node. So likewise, I keep on iterating it, and I make sure that the current pointer will hold the address of the last node inside my linked list. Once my current is pointing to the last node inside my linked list, I'll be assigning the address of the temp pointer, which is holding the address of a new node, to current's link part, and I return. Now let me explain the delete rare function. To delete the last node inside my linked list, I use two pointer variables, previous and current. Here I have to check for three scenarios. First scenario, whether my linked list is empty, when my linked list is empty. Second scenario, when my linked list is having a single node. Third scenario, when my linked list is having multiple nodes. First scenario, let me check. When my first scenario is when I do not have nodes inside my linked list. I check this with the help of first is equals to null. When will be the first pointer null? When there are no nodes inside my linked list. So if my first is equals to null, I print the linked list is empty and I return first. Second scenario is when I have only one node inside my linked list. If my first link part is equals to null. If this condition is true, that means I am having only one node inside my linked list. Hence, I print the first info part, and later I unallocate the memory occupied by that first pointer using the free memory management operator. So once that node is unallocated, I return null, which should be stored inside the first pointer. If that is not the case, that means my linked list is having more number of nodes. At least there are 2 nodes, or there are more number of nodes inside my linked list. Now I assign the address of the first node of my linked list to the current pointer. Now I have to traverse such that my current's link part is not equals to null. That means my intention is to hold the address of the last node in the current pointer and the address of the last but one node in the previous pointer. So I check for the condition while current's link part is not equals to null. I assign the address of current to previous. Now previous is holding the address as of current, and I want to move the current pointer to the next node. Where do I get the address of the next node? Inside the link part of current. Hence, I assign the current's link part to current. I keep on iterating this loop until my current points or holds the address of the last node inside my linked list, and the previous will hold the address of the last but one node of my linked list. So once this happens, I print the info part of the current, which is the last node inside my linked list. After the info part is printed, I will unallocate the memory occupied by that node using the free function. So once that node is unallocated, now the previous pointer, which was holding the address of the last but one node inside my linked list, is now the last node of my linked list. Hence, I assign a null character inside the link part of that node. So once it is done, I return the address of the first node of my linked list. Now let me explain the display function. If I want to display the elements of my linked list, there should be nodes present inside my linked list. If there are no nodes inside my linked list, that is, if my linked list is empty, I cannot print the contents of that linked list. First, I will check that. How do I check that? When my first pointer is holding the value null, that means there are no nodes inside my linked list. So first is equals to null. If this condition is true, no elements to display will be printed, and I return null, which will be stored in first again. If that is not the case, I have declared a pointer temp and assigned the address of the first node to that. Now I keep on iterating, or I keep on visiting each node inside my linked list with the help of that temp pointer. So until that temp becomes null, I print the value of temp. Temp's info part is printed. Once temp's info part is printed, I want to move to the next node. How do I move to the next node? I can get the address of the next node in the link part of temp. So hence I assign the address which is present inside the temp's link part to temp. So hence my temp will now hold the address of the next node, and I keep on printing the value of temp's info part until I reach the last node of my linked list. So once this is done, I return. Now I have explained you how I can insert elements from the rear end of the linked list, how I can delete elements from the rear end of the linked list, and to display the elements. Whenever we start executing a program, the execution always starts from the main function. So now let me explain you the main function. As soon as the execution starts, the execution comes to the main function. Here I have declared a pointer first and assigned a value null. Later I have declared two variables, item and choice. While one, which indicates a infinite while loop. I enter a infinite while loop and the menu is printed. Insert 1 for insert rare, 2 for delete rare, 3 for display and 4 for exit. I read the input from the keyboard which will be stored in ch variable, and later that will be passed to the switch statement. Depending upon my choice, the case will be executed inside the switch statement. If I have chose to insert rare, it will be asked me to enter an element. I read the item from the keyboard and store it inside the variable item. So once item is holding the value, I call the function insert rare, where I pass item and first as arguments. The returned values from that function will always be stored inside or assigned to the first pointer. So if I choose to delete an element, the case 2 will be executed where delete rare will be called. If I choose to display, I choose option 3. So case 3 will be executed and the display function will be called. So this happens until I choose the last option 4 to exit. Now let me execute this program and see how the output runs. A menu is shown, 1 for insert rare, 2 for delete rare, 3 for display and 4 for exit. I choose 1. I insert an item 10 inside the linked list. Again I choose to insert an element. I choose 20 to be inserted inside the linked list. 1, 30 I am inserting, 1, 40 I am inserting, 1, 50 I am inserting. I inserted 5 elements in total. Let me display the elements. 10, 20, 30, 40, 50. Because it is stack and I'm inserting the elements from the rear end of the stack. So first I inserted 20, later I inserted 20, later I inserted 30, 40 and 50. So that is the series in which the numbers are printed. Now let me start deleting them. 2. So 50 was the last item to be inserted inside the stack. Hence, it was the item to be deleted first. So let me again remove an element from the stack. So after 50, 40 was the next element entering the stack. So hence that was removed. Let me display the elements of the stack. Now I have 10, 20 and 30 inside my stack. Let me pop one more element to insert rare. So 30 got removed, 20 got removed, 10 got removed. Let me try to remove one more time because I know that 10 was the first element that was inserted and that is removed. Now my linked list is empty. Let me try removing one more element. Delete rare. No, the linked list is empty, is displayed. Now let me try to display the contents of the linked list. No elements to display. Now let me exit from the program 4. So this is how stack can be implemented using linked list. Same ways, using linked list, I can implement queues where I can start inserting the elements from one end and start removing the elements from the rear end. insert front delete rear will give me so a queue program. Likewise, I can implement double-ended queue where I can insert and remove elements from both the ends. Insert rear, delete rear. Insert front, delete front will give me a program for a double-ended queue. Hope you have understood how to execute and to implement the program here. Thank you.